Replication could increase performance and reliability of disk storage. A disk array is an arrangement of several disks. It can help achieve higher performance through data stripping and improve reliability through redundancy. Data stripping is distributing data over several disks. Through distribution, it can create an impression of a large, fast disk. Redundancy is having multiple copies of all or parts of data. The redundant information can help recover lost or corrupted data. Disk arrays that implement a combination of data stripping and redundancy are called redundant arrays of independent disks, or RAID. Through data stripping, a disk array provides abstraction of a single large disk, while data is distributed on multiple separate disks. The data blocks may be in one or multiple disks. How the distribution happens over multiple disks influences I/O request processing. The main goal in doing this is load balancing multiple small accesses on different disks to increase throughput and parallelizing large accesses to reduce response time. In data striping, the data is segmented into equal-sized partitions and is distributed over multiple disks. The size of the partition is called striping unit. Using a round-robin algorithm for data distribution among the disks, if we have D disks, the partition I will be written onto the disk I modulo D. If the striping unit is 1 bit, we call it bit-level striping. And if it's a block, we call it a block-level striping. One of the measures of storage system reliability is mean time to failure, or MTTF. Note that when we have an array of disks, MTTF for each of the disks affect the MTTF of the array as well. This could be considered independent most of the time, but there are times when they are not completely independent as well. For example, when something like an accident happens in a data center or the building the disks reside at, the failures may happen all at the same time. Redundancy is an effective way in increasing reliability because the redundant information could be used to reconstruct the data lost or corrupted. This will increase MTTF. Parity and error correcting codes could be used for providing redundant information.